Hi all! Let's jump into a demo of one of the key features of AG2's 0.5 release, FalkorDB's GraphRAG agent. We will also use a few other features, including the recently released swarm orchestration, newly available structured outputs, and an agent that uses the Google Maps API to calculate travel times. Here's our trip planner workflow. The objective is to work out an itinerary with our customer for a trip they're taking. We have 4 swarm agents and a customer. The planner agent works with the customer to understand the requirements. The FalkorDB RAG agent uses its GraphRAG database to get the relevant restaurants and attractions to help the planner. Once the customer has accepted the itinerary, the structured output agent will put that itinerary into a structured object using OpenAI's structured output capability. Finally, a route times agent will work through that itinerary object and calculate the times between events in the schedule, putting all of that into a final itinerary. Let's jump into the code. You'll find this notebook on the AG2 website. To start with, we need to pip install AG2 with the FalkorDB GraphRAG option. There are a couple more dependencies for this notebook. You'll need Pydantic version 2 or higher, and a Google Maps API key. See the notebook for more info on how to get one of these with free credits. You also need to have a FalkorDB running. Again, see the instructions in the notebook. Here we set up our LLM configuration, and as we'll need an OpenAI LLM for our FalkorDB RAG agent, as well as for structured outputs, we'll use OpenAI's models in our configuration. The data for our FalkorDB RAG agent will come from a GraphRAG database. We are going to load 3 JSON files of data on attractions, cities, and restaurants in Italy. These will be ingested, and the knowledge graph will be created based on an ontology that we're specifying here, made up of countries, cities, restaurants, and attractions. We must also include the relationships between these entities. Here we create our query engine, and we initialize the database, passing in our documents. At this point, they are ingested, and the knowledge graph is created. I'm just going to take a second to show you the FalkorDB web interface, which gives you a neat way of seeing your graph. Here's the trip data graph we loaded, and it shows all the nodes and relationships. Let's try and find Rome and some restaurants and attractions. These will come up in the demo. I can see 0 is the country Italy, and I know that Rome is the number 1 node. And we can see the other nodes related to them. Back to our code. Here we do our main imports. Here is the Pydantic model that will be the basis for our itinerary. We have a series of events, which are part of a day, which is part of the itinerary. Next, we have some functions that get the travel time between events. Using the Google Maps platform and the Directions API, we can get the walking time and distance between each event. We'll attach this to our route timing agent to use once the itinerary is complete. Swarm agents share a common context, and here we establish the starting context. We'll use the itinerary confirm to make sure the customer confirms the itinerary. Then we'll store the itinerary in various states throughout the workflow. We have 2 functions for our agents. One is to mark the itinerary as complete once the planner gets the confirmation from the customer. The second stores the itinerary from the structured output and then moves on to the route timing agent to populate the walking times. You'll see here that we check if the itinerary has been confirmed, and if it hasn't, we go back to the planner. Here are our 4 swarm agents. The planner works with the customer and can mark the itinerary as complete with the function when appropriate. The FalkorDB GraphRAG agent has the capability added to it. The system message is included when querying the GraphRAG database. The structured output agent has a response format set to the Pydantic model through its LLM configuration. This will apply to all of its responses. Here's the route timing agent and the function associated with it to do the walking time calculations. Finally, we have our human in the loop, our customer. Here are our handoffs and our afterworks for the swarm. These help us establish the flows and conditions between agents. The planner agent hands off to the GraphRAG agent whenever it needs more information. We try to ask it to do this only once, but it will occasionally try a couple of times. When the itinerary is confirmed, we'll head across to the structured output agent. When it has not done either of those things, it will revert back to the user or customer for more information. The GraphRAG agent always transitions to the planner agent. Similarly, the structured output agent will transition to the route timing agent, either through this handoff or through the function associated with it. Finally, the route timing agent is the last agent to operate in our swarm, and we want it to terminate the swarm when it has finished creating the timings. Finally, we can run the swarm. We start with the planner agent, include the customer as a user agent, our trip context is here, and we start by asking the planner to help plan a trip to Rome. Let's see it in action. Okay, the planner has asked us for more details, so we'll tell them what we want 2 days in Rome with lunch, dinner, and to see some attractions. We can see that the GraphRAG agent has been transitioned to, and it has provided all the Rome-based restaurants and attractions for the planner to reference. The planner has then created an itinerary. Now they're asking us if we're happy with it. We're going to ask it to change something. Let's change that last restaurant. The planner has used the knowledge it received from the GraphRAG agent to propose another restaurant. As a customer, we want to see them all, so we asked them to do some more research. At this point, if the LLM didn't feel it had enough information, it could revert back to the GraphRAG agent for more information. However, in this case, it uses the knowledge from earlier messages provided by the RAG agent to list them for a selection. I'll choose one, and then we'll get an itinerary we're happy with. This then triggers a call to the mark itinerary as complete function, storing the current text-based itinerary in the context variables. The LLM has also requested transfer to the structured output agent, so either way, they're next. The structured output agent returns a structured output. However, it doesn't call the function to store it and hands off immediately to the route timing agent. The route timing agent calls its function to update the itinerary with route timings, but in that function we can see that the structured output has not been saved, so it transfers immediately back to the structured output agent that then calls the correct tool, storing the structured output based on our Pydantic model in the context variables. It then transfers back to the route timing agent. In this final step, the agent works out all the walking times between scheduled events, updating the schedule and putting that final schedule into another context variable. The workflow is now complete, and we have a final itinerary stored in context. To view that, here is a fun, facts-ready output of the itinerary. We can see the walking times have been added in, and can give that to our customer. And that's it. Thanks to the community and contributors that helped make the 0.5 release happen.